Example, find the limit. The limit as x approaches 10 of x minus 10 divided by the square root of x minus the square root of 10. Before I do anything complicated, I should also check that this isn't as simple as just plugging in the value that x is approaching. If I try plugging in x equals 10, I end up with 10 minus 10 over the square root of 10 minus the square root of 10, which equals 0 over 0. This is my signal that more math is needed. We only keep working on a limit if we end up with an indeterminate form like 0 divided by 0. Since my original limit involves square roots, I'm going to try multiplying the top and bottom by the conjugate of the denominator, since the denominator is where the square roots are. The conjugate of a radical expression is just the same expression with the operation changed from either plus to minus or minus to plus. In this case, the original expression, the square root of x minus 10, has subtraction, so the conjugate will have addition, square root of x plus square root of 10. Multiplying the numerator and the denominator by the conjugate gives that the limit as x approaches 10 of x minus 10 over the square root of x minus the square root of 10 equals the limit as x approaches 10 of x minus 10 times the square root of x plus the square root of 10 divided by the square root of x minus the square root of 10 times the square root of x plus the square root of 10. Resist the urge to expand the numerator. In my opinion, it is better to wait and see whether we actually need to do something. Our goal here is to do just enough algebraic manipulation to get rid of the 0 over 0 issue. The purpose of multiplying by the conjugate is to get rid of the square roots in the denominator. So let's multiply out the denominator and leave the numerator alone, at least for now. I'll go through all the steps of carefully multiplying out the denominator, but before I do, I want to point out that there is a shortcut which explains why the conjugate is useful. If you look closely at the form of the denominator, it has the pattern a minus b times a plus b, since all we did to get the conjugate was change the subtraction to addition. This makes this the exact factorization of a difference of squares. You might remember learning in algebra that the expression a squared minus b squared can always be factored as a minus b times a plus b, just like how we factored x squared minus 4 in a previous example as x minus 2 times x plus 2. Here, we can take advantage of that same property in reverse. We are starting out with a minus b times a plus b. So rather than go through all the steps of multiplying it out using FOIL or some other process, we can just jump to a squared minus b squared, where a equals the square root of x and b equals the square root of 10. So a squared minus b squared equals the square root of x squared minus the square root of 10 squared, which equals x minus 10, since the square roots and powers of 2 cancel each other out. If we wanted to multiply out the long way, we could, and I will here just to remind you of how to multiply binomials, since that is an important skill on its own. Personally, I use the FOIL mnemonic. First, outer, inner, last. First is square root of x times square root of x. Outer is square root of x times square root of 10. Inner is negative square root of 10 times square root of x. And last is negative square root of 10 times square root of 10. When we clean that up a bit, we get x plus square root of 10 square root of x minus square root of 10 square root of x minus 10. And then we can see that the middle terms cancel, leaving just the x minus 10 that we got by recognizing the factorization as a difference of squares. However you get there, we now have that the limit we're trying to find is equal to the limit as x approaches 10 of x minus 10 times the square root of x plus the square root of 10 over x minus 10. Now I'm really glad that I didn't bother trying to expand the numerator. If I had, I might have missed that the numerator and the denominator have a common factor, x minus 10. Once I cancel that factor, I can say that the limit as x approaches 10 of x minus 10 over the square root of x minus the square root of 10 is equal to the limit as x approaches 10 of the square root of x plus the square root of 10. Now that we've done some algebra, we can try plugging in x equals 10 again. This time, we get the square root of 10 plus the square root of 10, which equals 2 times the square root of 10, which is just a number, not an indeterminate form, so we're done. The limit as x approaches 10 of x minus 10 over the square root of x minus the square root of 10 is 2 times the square root of 10.